So I would say good afternoon from my side, and welcome, Detroit and global SAE community. First of all, I would like to say thank you to the local chapter, to Stephanie and her team to putting together this event, and for inviting us, for inviting GAMIC. Most of you saw that already, what the topic of today's agenda is, but maybe we go a little bit, before we go into different startup presentations, a little bit in the background. So what is GAMIC? GAMIC stands for the Global Automotive and Mobility Innovation Challenge. We are heading now in season number 13. What is that? It's a competition organized by volunteers. It's not a company. And GAMIC is not doing that for profit. GAMIC is just able to do that with the volunteers and also together with the collaboration with SAE on a global scale, on a very local scale. And we as organizers, we just believe there must be that kind of catalyst to shorten the path to commercialization of innovation in the mobility space. We have seen how fast investment can support innovation. When we looked in the 90s in Silicon Valley, and we said, okay, we want to build a global ecosystem, a global community where startups can share their dreams and find partners, find facilitators, also maybe find investors to accelerate. And so that's what we're trying to achieve here. And we'll see 4 examples in this program today. Two words about my background. I'm coming from technology consulting background. I'm the CEO of Invensity North America. And my day job is to helping all these big companies to achieve engineering excellence. And I enjoyed very much for the last 4 years to give kind of my service and my coaching and my advice to the startup community for free as an in-kind service, and it's a real pleasure. And if you are interested in also becoming a coach or mentor, please reach out anytime to me and connect, and then we talk a little bit about GAMIC and what is happening in the background. But today we would like to share some already success stories. GAMIC is organized as a competition that goes over quarterfinals, semifinals, and then into finals. So last season we had 90 applicants worldwide from 4 different continents. And in the end, after procedures and presentations and coaching and events, we have 4 winners. And today these 4 winners are invited to show their technology, to show their path forward, to show their impact in what will be possible with their technology in the future. I invite you all, even though you're muted, please use the comment, the Q&A function in Zoom. We will look into your questions, and we will try to answer these questions along today's discussion. But let's get into the 4 companies. So we will start today with Hossein from Cirrus Labs, coming to us. I hope no one knows at the moment, because everybody is in kind of home office and also flexible where to work from. But normally he's coming to us from the Bay Area, coming from his postdoc position at the University of California, and started Cirrus Labs with colleagues. And yeah, and having that said, I'm very happy to see you, Hossein, again, and to set the stage for you here. Just give me a sign if you're already with us. Before we start the video, let's talk about one topic. How did you start your business? With a bucket full of money, with an idea, secured IP, with investors lined up? What was the situation when you started Soranus Labs?
Very to the point answer is we started off with an idea. It was basically a situation for us where we had a technology platform which was extremely sensitive and selective to specific chemicals. We were at the time exploring different market segments, and luckily one of the initial funding partners that developed this, that helped us develop this technology was Continental at the university level. So that from early on, we not just we had an idea that we would be targeting some certain applications in the automotive space, but as time went on and our relationship with Continental evolved, we started exploring more critical problems that are pertinent to today's automotive landscape, and that's how this idea of battery safety, early warning sensors for battery safety in EVs emerged.
Perfect. So now we're curious. Let's take a look. It would be fantastic if you could start the introduction video, and then we probably have one or two questions to go through afterwards.
Share my screen, and please let me know once you're able to see it. And I'm going to hit play. Hi there, I'm Fahad, co-founder and CEO of Soranus Labs, and we're developing early warning sensors for lithium-ion battery safety in electric vehicles. Now, we at Soranus Labs believe that the future of mobility is going to be all electric. Be it cars, buses, trucks, what have you, they're all going to have an electric drivetrain powered by lithium-ion batteries. That being said, one of the biggest problems facing this e-mobility future is battery safety, where in the past, catastrophic damage has resulted from battery fires. And these are some of the recent media highlights that have indicated the severity of this problem. Now, for OEMs, in the past, this was an issue of increased scrutiny of e-mobility as the future of transportation, as well as negative press. However, that is not the case anymore, especially in light of new regulations that have popped up in certain parts of the world, most recently and notably from China, where there is a mandate and a requirement for advanced early warning technology deployed in battery packs for new OEM EV models starting 2021, where the requirement is of advanced early warning in excess of 5 minutes to alert the driver of a potential catastrophic failure. Now, that is not currently possible with existing technology today. And I'll explain to you why that is the case. Now, before that, I'd like to very briefly talk to you about battery packs in general that are used in EV OEMs today. So OEMs use one of three kinds of lithium-ion cells. There's the most popular pouch cell, there's the cylindrical cell, and then there's the prismatic cell. But regardless of the cell type, OEMs always arrange them into groups called modules, and a bunch of modules basically make up a battery pack, which usually forms the under chassis of the EV. Now, the battery health today is measured at the module level, and the parameters that are measured are usually temperature, current, and voltage to detect potential catastrophic failure. However, to meet this new requirement of advanced early warning in excess of 5 minutes, monitoring these parameters are not sufficient because they change dramatically only at the moment of catastrophic failure. So what we propose to do is measure trace amounts of vented gases that is released from lithium-ion cells at the onset of, at the earliest onset of catastrophic failure. And we propose to do that by deploying our proprietary gas sensing technology at the module level to predict battery failure by measuring trace amounts of vented gases like hydrogen, carbon monoxide, carbon dioxide. We specifically want to start off with trace amounts of hydrogen because this is a gas that does not exist in atmosphere at very high concentrations. And also because it is an early indicator of failure. With that being said, let me very briefly talk to you about our technology. We call it Lichens. It is a silicon-based technology, and in its chip form, it looks like this. And when observed under a microscope, it shows basically the different transistor patterns and sensor patterns that are incorporated onto the chip. This is a chip that measures about 0.8 millimeters by 0.9 millimeters, and it is manufactured using conventional silicon processing techniques and is based on UC Berkeley's proprietary gas sensing technology platform called the Silicon CS FET. Here, the enabling component is this extremely thin, ultra-sensitive and selective gas sensing catalyst layer, which is a proprietary material that is extremely sensitive to trace amounts of vented gases. In our case, it's hydrogen. It is a cost-effective, highly scalable, and small-size technology. It is so small that we could, in fact, integrate it at the individual cell level, opening up a plethora of new applications that we're currently exploring. Now, within the automotive value chain, we see ourselves as a tier 2 supplier that manufacture and package and calibrate our sensors and then sell them to tier 1 systems integrators and suppliers who then integrate it as part of a battery management system, who are our customers, by the way. And then these customers basically hand this integrated product over to the EV OEMs or end users. So this basically captures our business model. With that, I'd like to very briefly talk to you a little bit about some of the traction we have recently received in terms of a completed project with one of the major tier 1s. So late last year, we started a project with Vitesco Technologies, Continental's electric powertrain company, where we supplied our prototype sensors and hardware. And with our technology, they were able to observe at least 10 minutes of advanced early warning, beating existing sensing modalities such as temperature and voltage in a variety of lithium-ion pouch cell abuse tests, such as electrical and thermal, or external overheating and overcharging are examples of these abuse tests. So we're really proud of this traction, and basically shows the applicability of our technology in this rather critical application in the EV industry. In terms of market opportunity, we see a total market opportunity of $2.8 billion estimated for 2025. I say estimated because vented gas sensing as a sensing modality does not exist today in EV battery packs, making this effectively a new market. The market for battery safety components today comprises of voltage, temperature, and current sensors. In 2019, this market was about $1 billion in size and is expected to grow to $5.7 billion in 2025. Now, the assumptions that we have made for this market is that we would be integrating our sensors at the individual module level of a battery pack in an EV, and the average module count across different EVs and different OEMs is approximately 14 per vehicle, which equates to about 14 sensors per vehicle. Now, the drivers for this market are obviously an increasing demand for EVs, where in 2019 there were about 5 million manufactured, and in 2025 this number is expected to grow to 40 million. There's also the demand for fast charging, long range, and safe battery packs, as well as very importantly, mandatory safety regulations, most recently from China, as I've mentioned. In terms of competition, and purely from a technology standpoint, we see metal oxide gas sensing technology as our closest potential competitor, purely from a cost and scalability point of view. These are some of the manufacturers that make them today, and none of these manufacturers, except for one, has an application geared specifically towards battery safety monitoring using their gas sensing technology in electric vehicles. So we took one of these sensors and benchmarked it against our technology, and what we've seen is that we're a more sensitive technology and we are a fast technology, two very important attributes when considering the safety critical nature of the application at hand. Furthermore, metal oxide gas sensing technology is not a good solution for the application at hand because it is a non-selective technology. Now, as you can imagine, when deployed in a battery pack in a moving vehicle that moves around in different parts of a city and is subject to different parts of atmospheric pollutants, these sensor technologies have a tendency to give false alarms in the presence of confounding atmospheric pollutants. Compared to this, we don't have that issue. Furthermore, metal oxide sensor technology runs really hot. There's a high power requirement, and based on our direct interviews with OEMs, high power requirement is a no-no, especially for peripheral electronics that are there to ensure battery health. With that, I'd like to very briefly talk to you about our team. We started off with two co-founders, myself, and I'm currently the CEO and CTO of Serenas Labs, and Ali Javi, who is also a co-founder and our chief science advisor. So I was a postdoc in Ali's lab, and together we co-invented the technology called the CSFET at UC Berkeley. Very recently, we onboarded and welcomed Chris Pister, who is also a professor at UC Berkeley and Ollie's colleague. He's a member of our advisory board. He's very widely known in the broad field of MEMS and is specifically known for the inventor of smart dust technology used in oil and gas wireless sensor networks. With that, I'd like to very briefly talk to you about our company history. We were incorporated in 2017. However, we did not start operations until the third quarter of 2018, when we got our first funding in the form of a NASA SBIR grant to develop our CSFET core sensing technology platform. We then got a second funding from NSF SBIR, which the project which we completed this year. And as I mentioned, we started a technology project with Vitesco in late 2020, which we concluded at the end of January this year, and achieved these advanced early warnings in excess of 10 minutes for battery safety. In terms of other markets beyond automotive, we see applications for battery safety in aviation, new forms of electrified mobility in developing countries, especially all forms of mobility in developing countries that are being rapidly electrified under government regulations, electric locomotion, aerial mobility, as well as new forms of urban mobility. In beyond mobility, we see applications in energy storage, micro and nano energy utility grids, as well as personal consumer electronics. With that, I'd like to thank you for your attention, and if there are any questions, I'd be more than happy to answer them. Thank you.
And I bet there are questions. Maybe to a pretty obvious one, lifetime. When we want to bring a technology like this in the automotive space, then lifetime is a pretty important one. So what is your current estimate of durability? Do you more have an orientation, or do you make targeted to durability that fits to the life cycle of the cell, of the battery module, or of the overall vehicle, where we have really in a passenger commercial vehicle space different lifetimes? So what's your current estimation?
Yeah, so I would like to basically answer that firstly from a technology standpoint. So from a technology standpoint, we utilized inorganic solid state materials. So naturally, we feel, based on our current estimates and our current analysis, that this technology is competitive to the metal oxide semiconductor, which is coveted for very long lifetimes, in excess of 5 years. However, we are targeting lifetimes with our sensor technology for the life of the vehicle, which is roughly about 10 years. That is the lifetime that we're targeting, and we are quite confident that we can meet that specification.
Very interesting, yeah. Another question that comes up, because we are in a SAE context, where would you like to see more activities from the policy side, from the standardization side, from the SAE community side, that might even support your technology?
Right. Okay. So first of all, battery safety is going to be a problem for now, as we move from now to the future, foreseeable future, regardless of the kind of batteries that you're packing inside the vehicles. This demand is only continuing to grow, will continue to grow, especially as customers require fast charging and parity with ICE engines and long range. So from that perspective, we see that the demand for this advanced safety is actually going to be driven more from the regulatory side. So we would like more, push, or I guess outreach from the regulatory side down to the OEM. I mean, the OEMs, of course, want to advertise a safer vehicle, but the cost will add on, and OEMs it's pretty traditional mindset that right now they don't want to invest, or they don't want to dump in too much cost into the vehicle if there's no need for it. But personally, and also from the company standpoint, I would basically like to see more interaction on this topic from the regulatory side, and basically from the SAE community.
Yeah, thank you for the answer. For our next presenter, we will introduce Assam. Assam, not coming from the West Coast, very close. And it's so funny. So we are organizing a global Automotive Mobility Innovation Challenge with like attendees from 5 continents, and then we have a winner from right around the corner from Ann Arbor. So graduate from University of Michigan, Dearborn, Go Blue, and kind of coming out of this autonomous vehicle ecosystem, accident avoidance, safe mobility ecosystem that is evolving in Michigan. And so I'm happy to see you here again. Let's give Stephanie some time to get your little also introduction video ready. Hopefully, picture perfect on the audio side. When it comes back to you, it's that we will see that you have a technology in the computer vision field. So maybe a little bit a business question. I said, now you're getting the word out. What is your current challenge and what is the next step that you are facing from a business perspective, not so much from a technology perspective?
Well, yeah, I just want to start. Can you guys hear me very well?
Yes, crystal clear.
Perfect. I'm glad to see that. So yeah, so from our perspective, in the term of the business side, from our side, we actually, since we are working with some of the top automotive suppliers, one of the challenges that we have noticed is due to the COVID-19, it made some impact on businesses, including our company. It's kind of slowed things down, but I'm very glad that right now we started to see the automotive is back on track, and we are right now going back to finishing and start working on some of the the development contract that we were doing before. But yeah, I would say the most challenge that we are actually facing currently in terms of the business side is how can we interact with our customer. And the way to do that is we want to interact in person because we feel better and we know how our engineers team can interact with the other engineers team since our technology is relevant to building the system into the vehicle. So, it's hard for us to do it virtually. Imagine, trying to do testing virtually. From our perspective, we want to do our testing, our development in person. So that's the challenge that we noticed in the past few months. But currently, right now, what we're doing is we're actually sharing data between like our customer and us, and sharing that result and just using some cloud-based, using Amazon AWS. It was quite challenging for us, as I mentioned, because our company is really heavily rely on interacting with customer in person, because we do a lot of testing, we do a lot of integration into the vehicle. But I'm glad to see that things are coming back to work and people are going back to work as well. And there's some right now, people are start to interact with one another. So that's a good news so far.
Mm-hmm. Yeah, I think you made a good point. Is that especially in this high-tech environment, we're used to go on conferences and meet future project partners, and now these are partially virtual, which a lot of I know it from my customers is that not everybody has time because everyone's business changed and everybody is fairly busy. So would you say they're, let's say, missing virtual market spaces where you can not just like here promote a little bit your technology, but really go in an interaction and have a virtual space to validate your technology? Is that something that you're missing, or something would you say, oh, this is existing and I know a good one?
Yeah, I would say it is something that, so here's the thing. So COVID-19 actually changing the way we live. And I see that in a positive way. Not to mention the school, people are right now going virtual, learning how to learn from home. It's the same thing for software companies like us. We have to adapt. We have to learn how can we interact with customers virtually. Not only that, like events like this, CES, we need to be able to interact with one another just only virtually. And I think that's a learning experience for all of us that we're doing. It's to see how we can avoid all the technical challenge and to move on. I think that's a good learning experience for all of us. And I do see the positive side from this. And not to mention, virtual using Zoom and so on, it will allow us to interact with people from different countries, from different, long distance. So that's a really, really powerful tool that we can use it and leverage this tool to be very productive. Because sometimes you might be traveling from location to another and you're spending tremendous amount of time. So if we can use this technology for the positive things, I think we can be in a better position in the near future.
So, yeah, I agree. Let's take a look into your technology. I think we have a video presentation prepared. Oh, Stephanie. So yes, we do hear something.
Okay, so my name is Assam Zucker. I'm the founder and CEO at Info. Info is a startup here located in Ann Arbor, Michigan that focuses on understanding and predicting how pedestrians behave around the autonomous vehicle. When you hear the name of Info, we would like you to remember us as just one thing. Info is more focused on pedestrian safety, and that's exactly what we do. We believe that autonomous vehicle will change the way humans actually live around cities because the autonomous vehicle will bring in a better way for human to transport from one location to another in a much safer way. And the reason why, because human drivers are not the best out there, because when we drive the vehicles, normally we are really distracted. Today we have a distracted driver, but also we do have a distracted pedestrians, and that's a deadly combination. Since the beginning of our company, we've been focusing specifically on this niche problem. And the way we do this is we're using computer vision and machine learning to recognize and predict how these humans behave around the vehicle. And based on that information, we take that data using machine learning, and we feed that data into our machine learning model. And based on that information, we can send the signal to the driver, alerting the driver of the surrounding. And each individual model focuses on a specific use case scenario. For example, one model can focus on the intent of pedestrian. Second model can focus on the distractions level. All of this data is, giving to our predictions model, where we take the predictions and alert the driver of the surrounding. And actually, the beauty of our technology is we are assigning a risk level to each individual person, which means that if a person is distracted and he's crossing the road, we are classifying that person as a high risk. But if there is a person who's just standing on the sidewalk and he's actually paying attention to the vehicle, he's aware of the surrounding. So we assign a low risk for that person because we know that that person is aware, he's not distracted, and he's around aware of the surrounding. This is exactly the same way as human driver drive the vehicle. When you drive a car, you are immediately knowing the behavior of that person. So this is exactly what we're doing at Info. We're actually leveraging the exact same information the human being has been learning since they were kids, and then taking that data and continue to learn as they grow. That's exactly the same way as we teach our model. Is we capture as much data as possible from the road environment, and we take that data and we feed it into our model where the model can learn and continue to learn and grow. We are here at Info, we're not coming to replace any existing system. What we do is, since we're building the software, we are actually coming into the automotive suppliers and we're using the existing object recognition system that has been built in the market, and we're just only coming in to add additional behavioral model, which provide much rich information what you have already built in the market. So it's a great technology, and we are here at Info wants to be part of this and address one of the main biggest problem, which is pedestrian safety. And we hope that one day in the future, we will make a difference.
Wonderful. Thank you, Assam, for jumping in and sharing this working and easy to understand video. Let's go a little bit a layer deeper. This sounds all fantastic, and I think when we went to our first driving lessons, the instructor told us to have eye contact. So how does, give us a little bit insight, how does your algorithm work? Are you more looking into, can your algorithm identify the eyes? That might be difficult because the resolution of the camera that we are using in a mobile application might be not sufficient to do that. So it's like head position. So give us a little bit, not the deep dive, but a little bit insight on what are the pillars of your algorithm development.
Great question. So first, I would go ahead and start explaining exactly what has been built on the market, which I explained a little bit on the video. So in today's market, we have a big, automotive suppliers. We have big OEM that has been focusing on building the current system, which specifically focusing on the object recognition. What I mean by that is you are trying to identify a pedestrian, you're trying to identify a vehicle, a bicycle, motorcycle. That's what has been done today. And also the current system is today is more focused on the tracking. You track an object using the computer vision, but also you're looking to classify that type of object. So here at Invo, we are leveraging and using that system that has been built in the market. So we're coming in to just saying, okay, how can we identify the behavior of that person? How can we recognize if that person is aware? As you mentioned, if he's looking at the vehicle, at the driver. And the way we do that is we're using machine learning. And machine learning is a very powerful tool that we can leverage and use today is to extract some features from the human body. For example, we can look at the eye contact, looking at each individual eye and see if you are looking at the driver. Obviously, it's going to be difficult for us to see the eye, especially in the long distance when you have a vehicle is moving 50 miles per hour. But also we are looking at the head position, try to identify where are you looking? Are you paying attention to the driver? Have you ever seen a vehicle coming through? So all the information, but also trying to understand your feet position, your arm position. All the information is so critical for us to identify if you really had the intent to cross the road. In addition to that, we're looking at the environment. So we call it environment cues. So we try to identify the traffic light and try to understand the road lanes, if we have 4 lanes, 2 lanes as well. And also looking at the sidewalk. In addition to that, we can look at the traffic sign, anything like that give us a better understanding of the environment. So all of this cues is so critical for us. So we are using kind of a machine learning to extract all this feature in real time. So today we are able to achieve 25 frames per second using NVIDIA Xavier. And we're actually launching this system and deploying it into one of our customers. It's an OEM customer that we're actually deploying in the next few months. It's a great technology for those customers who's actually building the object recognition system, and for those who recognize that pedestrian safety is a very big concern for them. So we are here as a company who wants to help and support this kind of the challenge that they're facing.
So now you made us curious. So when are you able to disclose this OEM you're already working with to make our own lives, or make especially autonomous vehicles safer?
Yeah, definitely. So this one of the OEMs. So we're hoping that we will disclose once we finish our second phase with that with the OEM. It's one of the top OEM. They are based in Europe, but they're a big OEM. So hopefully very soon we will disclose this type of OEM that we're working with. In addition to that, we're working with the second automotive supplier as well here locally in Michigan.
Mm-hmm. Maybe a question that is also important from an SAE perspective. We have seen in the past that in the end, investment in new technology in the automotive space is coming for 2 reasons. One is profit, and the other one is a requirement by a policy. And so especially when we talk about these safety features, it all kind of comes together with NCAP tests. So NCAP tests that in the end we all know as 4-star, 5-star, 3-star rating. We introduced the first pedestrian and bicyclist detection, I think, with NCAP 2020. Do you already know when we see a pedestrian let's say awareness, pedestrian awakeness rating in that NCAP test catalog?
Yeah, I think that's a very good topic that you mentioned. Hopefully, I mean, this area has not been so much focused, especially in the automotive. I mean, there's not many. I mean, obviously, there's a big companies out there who's trying to address safety. But when we talk about safety, we think that pedestrian safety is the biggest obstacle for those OEMs, automotive suppliers who's building this kind of technology, especially when you're looking into building a shuttle bus or an autonomous vehicle. So we totally understand that pedestrian safety is their biggest problem, because if you get involved in an accident with the pedestrian or in a fatality, that's a big liability for these companies. And the question is, who's responsible in this case? You know, obviously, when you have a robotic that is driving in an urban environment and you get involved in a fatality, that's a big liability for these companies. So we are expecting that in the near future that there will be has to be some kind of exclusive testing specifically on pedestrian safety. Any technology, especially when it comes, you know, rely on machine learning, we are, you know, expecting that there will be some regulation that will be done in the automotive, because in today's market, what does it mean accuracy is accuracy? Like, there is so many companies out there who's building a technology using machine learning, but there's no standards out there that say, in order to deploy your technology into a vehicle, you have to achieve at least 90% accuracy, and you have to meet all those standards. So I think that's where here at CES, or kind of type of event, that we want to come together as a team and try to define what are those strategies that we have to come up together, and how can we define safety? How can we make sure is all those companies who's building this kind of technologies are meeting the safety standards? And I definitely believe that there will be some standards in the near future, but we have to take a step further and supporting that. And we are here at Intel wants to be part of this, and we want to support and make sure that even our technology that we're building, we want to make sure our technology is really safe. And we cannot do this alone. That's the reason why we rely on automotive suppliers and OEM to help us to get there.
Yeah, I think it's pretty obvious. I think in this NCAP standard, you get 2 points, 2 extra points when you have an attention assist. So that means you recognize the attention of the driver. So why should we not get additional safety points for recognizing the attention level of our pedestrians that are in front of us or behind the vehicle? Now I can see that, absolutely, especially in the shuttle case where you have people crossing very close to the vehicle in front and in the back. So, but that sounds all fantastic. I'm pretty sure you're not the only one in the room in this space. Do you know who's your competitor? Who's working on the same thing? Who are you racing against?
So yes, we're racing with other companies in the space who's actually racing toward the same solution that we're building. So there is 2 companies that was actually building similar technology to what we're doing. So we have a company in here in US in Boston. It's called Perseva Ramada. They also focus on the exact same technology in terms of pedestrian safety. Also, there's another company in UK. It's called Human Autonomy. So obviously, we are the 3 companies so far who are specifically focusing on the kind of pedestrian safety relevant to human analysis. But not to mention, obviously, there's other big companies in the space. You're talking about Uber, you talk about Lyft, you talk about Waymo. Of course, all of these companies is actually working to build their own full stack system. Again, we definitely believe that pedestrian safety needs its own focus, and it needs its own team and a company that really gets addressing this problem. And not to mention, Info is located here in Ann Arbor, Michigan. We have a big advantage than other companies who's working in the space. Not to mention the weather condition that we're actually leveraging here in Michigan, it gives us a much bigger advantage. In addition to our strong relationship with the big automotive suppliers and OEM. Again, majority of our team has been working in the automotive space, including myself. So we know the space that we're trying to address. We know the customer we are working with.
Thank you. I hope you're winning the competition. And maybe even Absolutely. In this room, we have a few attendees. Maybe someone is even involved in let's say NCAP or autonomous vehicle safety discussion and policy side. Yeah, also to the audience. Don't hesitate to reach out to our speakers today and kind of follow up on what's possible. Because when we recognized in the 2000s that automatic emergency braking is possible, then we made it a policy.
Correct.
And I think it saved already some lives. So thanks for that.
I agree. Yeah, I agree. Yeah, it's similar to what happened to the automatic braking. We are hoping this exactly is going to happen the same thing to pedestrian safety. Again, because since we're racing toward building an autonomous vehicle, we believe we're going to go in that same directions in the near future. So.
Thank you, Asaf. We want to move forward a little bit different. We are staying in the computer vision space, but Now it gets a little bit more deeper in the engineering side of things and how to scale computer vision and control it. I would like to introduce Yasser Khaliji from Caliber Labs, not calling us our international today. Kind of also coming from a US West Coast school with a lot of professional stops and academic stops, but now working out of British Columbia, my favorite place to go skiing, not to go really on a long time. But very interesting. Also one of our winners of this year's GAMIC competition is with and representing Caliber Data Labs. And before you start your video, I think that worked very well already. Maybe we also try that you do that yourself. Before we go in that, I said what Asam already talked about, the current situation, that it's difficult to interact with clients, with project partners, to find new project partners. How is your business impacted by this situation in 2020 during a pandemic? Next year, it's another financial crisis. The other year, it's a completely, let's say, blow up of oil price. So I think we will have more disruption in the market coming from external factors. Well, how robust is your current business, or how do you adjust in these times?
Okay, thank you so much for the good introduction, Fabian. Can you hear me well?
Very well.
Okay, excellent. Yeah, so regarding the question, as some also mentioned, yes, we are impacted as well. I think for a startup, versus any small company, one of the biggest challenges at the start is to find the right partners, and it has specifically affected us because we are building deep technology for scalable data platforms. And we, in order to show our traction in the market, we are relying on partners that have a large fleet of vehicles that collect a lot of perception data. So in that case, I think the pandemic slowed us a little bit because we want to reach out to the OEMs and tier ones to and their research team, and those teams, they have been adjusting to this new normal as well. But then I think in the long term, this pandemic showed that we can be much more reliant on automation and AI in general. So I think putting my positive eyeglasses, I think in the long term, this problem added quite a bit of value to going towards automation, and specifically a perception automation.
And I think I think the audience will even agree once they see your technology. So maybe let's not let them wait. Let's progress a little bit and go into your technology, and then everyone else in the room will understand where collaboration and perception data comes together.
Okay, so in this presentation, I'm going to showcase our flagship product, SceneBox, which is the data platform for machine perception. So in the last few years, we have seen an emergence of intelligent perception systems. Autonomous vehicles and ADAS systems deliver robots, collaborative industrial robots, and automated drones are good examples of these intelligent perception systems, where the commonality of these these machines are that they collect a lot of perception data, and the whole system becomes more and more intelligent using machine learning and AI. Now, building this intelligent solution requires a data management platform that consistently collects a lot of edge perception data and systematically build machine learning models. So we did quite a bit of research in this field and talked to quite a few machine learning and perception teams, and we realized that building the machine learning algorithms and the architecture of them are actually not that hard. The real problem is the data. And then the data operation is something that takes a lot of time in the life of a machine learning engineer, like how to store it, how to how to label it, how to find balanced data set, how to augment the data, how to find the right labeling partners and things like that. Okay, so we call these data operations for machine perception. Now, when we go to automated driving, this problem becomes even more significant because these type of systems, data platform, need to operate in the intersection of data quantity and data quality. So if we are considering a self-driving car, it conservatively generates 4 terabytes of data per day, because it has usually multiple like high resolution, high frequency camera, and it has usually some like LiDAR systems in it. So if I want to translate this amount of data to $ and time, if you only have a fleet of 100 cars, it takes 1 year to transfer a single day of data over a premium plan. And the annual storage cost on Amazon S3 is around $20 million. Now, not all of that data is useful. Probably 95%, 99% of the data is something that the machine learning algorithms have already learned from. And then only a small amount of data, like under 1%, is something that is actually useful. Now, this quickly becomes a needle in a haystack problem that machine learning engineer requires a tool set that says, okay, I'm interested in all the left turn scenarios in a snowy condition at night, in the state of Utah, that there is a pedestrian and a truck in the scene. So I want to use this data to improve my model. And the platform should go through hundreds of terabytes of data and then finds a handful of images that could satisfy all of these conditions. Now, the real pain is it takes a long time to build this type of operational end-to-end platform. Usually the cost of development is millions of dollars. A handful of companies has been able to make this type of platform, such as Tesla, NVIDIA, and Apple probably. But if you are not one of these companies, you usually don't have that type of infinite budget and access to talent. Now, the last problem is that if even you build it, you have to constantly integrate it with all the AI data provider ecosystem. So it becomes very expensive, very hard to manage. Now, our solution to this problem is Scenebox, which is an edge-first data platform that streamlines all the AI data operations for large volumes of perception data. The benefits of using this platform for machine learning engineers is that they can build better training data sets faster. They can focus on building model rather than pipelines. And then they can reduce the machine learning product time to market significantly. Our end vision for this product is to build a smart end-to-end perception platform that allows machine learning training and testing at petabytes of scale. So I want to emphasize it needs to be a smart bit, because when you go to petabytes of data, you cannot review the data manually or even semi-automatically. So the process of data collection and curation needs to be done intelligently. The other part is that we need to productize this type of solution, so we can actually go from client to client, from environment to environment, so we can enable adoption at a scale. Now, how do we do that, and what is the secret sauce? I would say that the architecture of our platform allows us to actually do this type of data operation at a scale, because what we do is we analyze and featureize the data at the edge, and then we only send this summarized and featureized data to a centralized solution. So without moving the data that much, we would be able to have access to all of the data that is generated within this type of distributed systems. So now the machine learning engineer can access the the summary of the data and knows where are the right or interesting scenes are happening without having to transfer all of the raw data. Okay. Now a little bit about the product itself. Data platforms and data management solutions, usually multi-audience platforms. So you have to build different type of interface to address different type of teams. So we build a rich GUI, for this solution that usually perception teams and QA teams require. Software engineers and data annotator usually integrate with the REST API. So we build our platform as a REST first platform, so it could be integrated within their workflows. And then data scientists and machine learning engineers, they heavily rely on Python clients. So we build actually all of the operations that we do in our data platform is done, could be done by a Python client, which integrates with Jupyter notebooks. So we have some very good feedback from our early engagement. There's a couple of interesting, testimonials from a chief data scientist at Motorola Solution that they build scalable surveillance systems, and also a senior engineer at Postmates X that they build sidewalk delivery robots. So in terms of the company, we are a year old. We are located in Vancouver, Canada, and the ML team is in the San Francisco Bay Area. We are, good engineers and researchers from, well-known universities and research centers. Team of technical folks. And I also want to emphasize on the advisory team, specifically Jeff Warwick, who actually became our advisor as an outcome of, our GAMIC challenge. So he was, our, coach. And then after the challenge, we asked him to join our advisory team, and he kindly accepted. So the ask, go ahead.
Please, I give you another 20 seconds.
Yeah, so the ask is that we are, want to talk to, GAMIC partners and to learn more about OEMs and tier ones data bottlenecks. And, we are interested in pilot engagement with tier ones and OEMs, and eventually we are very much interested in partnerships. This is my, contact info. Would love to learn from you guys.
Very good. I think very interesting technology, especially because you're not working on a technology that goes in the product. You're working on technology that enables engineers to globally collaborate and getting this huge amount of, especially computer vision data under control. And I think everybody, there might be the one or other in the audience who's right now building software teams and computer vision teams or other big data teams, and said, okay, how do I organize that these people collaborate? So I think very interesting. We talked already a little bit in the beginning. I'd like to move forward a little bit, that we stay in the time frame. With also colleagues from the West Coast that still have a working day in front of them. So let's keep that, stay on. We will see what are questions that are coming in. So maybe we come to a little bit Q&A later. Now I would like to come to our presenter number 4, James Bankister from down south, Texas, coming to us and not coming from a software environment, but a little bit related to battery and e-mobility safety. So maybe also we had an interesting discussion in prior, how can policy that is influenced by SAE help startups? And also you're working in a technology that hopefully increases safety. How can the SAE community help you to scale in terms of what policy do we have to write to make your technology more successful?
Crash safety is largely dependent upon, this sounds terrible, shaming automotive manufacturers sometimes into improving safety. And the test houses, the Institute for Highway Safety and the Insurance Institute sometimes has to institute new crash tests to demonstrate, or at least raise the flag on certain flaws of performance on crash safety in vehicles. And in our case, the small overlap and the oblique test that's upcoming are tests that have been created to identify or to highlight performance flaws in the current generation of vehicles. So unfortunately, there's a lag between designing a test to identify a flaw instituting the test, and then chance for manufacturers to start improving their performance in those tests. So there's kind of a lag well after the time in which crash safety issues have been identified before the entire industry tends to focus on it, which is what's happening in the overlap test.
Yeah, it's sometimes hard to fix the problem that late. It's not hard. It's impossible. It's impossible. So we're super interested in seeing more from your technology.
Hi, thanks to the Detroit SAE chapter for hosting us tonight. I'm here to introduce you to Tesseract Structural Innovations on behalf of our lightweight solutions for crash energy absorption save lives. 25 years ago, our founding inventor, Henry, was in a small overlap crash. Didn't know much about it at the time, but that was 7 years into his career as an automotive engineer. He was really surprised with his background in automotive engineering that the crash was a relatively small crash, but caused as many injuries and damage to the vehicle as it did at the time. He set out for the next 20 years to understand overlap crashes and started identifying ways to improve vehicle performance in these overlap crashes. This small overlap crash he was in, or also called the never offset, is disruptive in terms of it causes disproportionate number of injuries and deaths than it does than the number of crashes. These 17% of crashes cause 25 to 34% of crash deaths. About 10,000 people die each year in these crashes, but there's no universal strategy to target them. The problem that I'm sure everyone in this room knows is that vehicles absorb crash energy in load paths, but not all crashes hit those load paths. And it's just not feasible to add more steel to the problem. So what we've identified is an opportunity to improve on it. The current strategies have limited effectiveness and include occupant compartment reinforcement, early engagement structures, shotgun structures, load path fuses, and so forth. But what we've designed is a solution to all these. I mentioned the disparity around the number of crashes and the injury rate and the death rate for those crashes. And what has happened is the Insurance Institute and the National Highway Traffic Safety Administration has developed and is developing crashes to try to target vehicle performance for those. The small overlap crash and the moderate overlap crash have been out for a number of years. These impact different locations in the front corner of the vehicle. The small overlap crash missing the frame, which is why there's a high injury and death rate there. But unfortunately, the introduction of these crashes has not resulted in a significant performance improvement of the crashes. So NHTSA has developed the oblique overlap crash test that will help identify performance improvements that may improve and save lives. Our solution is what we call a uniform deceleration unit. It's a lightweight metal composite that can be easily integrated into a vehicle, but absorb up to 75% of crash energy. And the key point here is that a UDU absorbs more energy than any other approach per unit of added weight. You see the image on the right shows how our UDU would be implemented in the frame of a light truck vehicle in the front fender. We also have a solution that's targeting the side sill to protect batteries. You see the side pole crash test on the left. This is designed to determine the impact of to a door to protect the occupant. But now that more companies are placing a large battery underneath the vehicle occupant compartment, there actually is risk of this test exposing performance problems in side pole test because of the battery. And if you try to maximize the battery size underneath this, you're actually getting pretty exposed to the side sill that you do. Our UDU that we designed here absorb 40 to 94% more energy placed into that side sill, which allows an OEM to maximize the battery size without putting that battery or the occupant compartment into more risk from the side pole test or the crashes. Okay, now I'm going to talk about some of the key concepts of our UDU solution, maybe some of the secret sauce that goes into our engineering principles. Concept number one is we're going to bring the load up to a target maximum force. Concept number two is we're going to maintain that load near the maximum. So to picture this in your mind, think of an aluminum can, maybe a Coke can, or some of you are more familiar with a beer can. A Coke can, if you look at this graph, is very strong and resists a lot of energy and force until it's not. In the process of crushing and collapsing, it is a very peak load here. If you picture aluminum foam or any kind of foam, aluminum foam can absorb energy slowly until it starts approaching a solid state. So the green curve or the red curve here shows what the aluminum foam will absorb. Well, what we've done is what you would see if you've ever accidentally crushed an aluminum can that still had a little liquid into it, that it would absorb energy and resist the crush a lot differently than an empty aluminum can. So the combination of the aluminum skin and the aluminum foam starts approaching that maximum target force. Now, if you stack a second can or a second UDO cell up next to it, you sustain that force further. So this shows the crush result profile of a 3-layer UDO. Let's talk about the validation. We've actually developed a 4-layer crash test that we did at NIR. And what you're looking at is, number one, it brings the load up to the target maximum force. Number two, it maintains that load. But if you look carefully at this graph, we're actually slowing down the crash with concept number 3. So we're bringing that load up there. We're trying to get it as close as possible. And this crush test showed physically the results of this 4-layer crush. It actually has a slope to it that absorbs more energy as it proceeds, which in turn slows the crash down for the vehicle compartments. We also have a full vehicle UDO crush simulation with our UDO placed in a light truck frame. We don't have time to go into that now, but would be happy to schedule a meeting to go with you for more information of how the UDO performs in a full vehicle simulation. Now, the company's intellectual property is protected by multiple patents filed, pending, and issued. We had our first 2 patents issued this year, and we're excited about that, both US and internationally, and we have several more that are on the way. We have multiple product opportunities, and we've identified 16 potential vehicle components covered by IP filings using the UDO concepts that I've talked about before. Our business model is to be a parts supplier, so we're bringing up manufacturing capacity as well as looking at some outsourced manufacturing opportunities. We do or will consider design licensing if there's a tier 1 supplier, an OEM that wants to come to us with a custom engineered solution. This particular screen shows our side sill battery protection UDO on the left, a bumper box to mount on the frame, ends of the frame, and 2 different versions of our fender mounted UDO, a vertical one for a relatively tall, skinny fender shape, and a more flat horizontal one, both of which can capture a significant amount of energy in a crash. Our competition, of course, is the current energy absorption of redirection approaches that we've shown tests we can exceed significantly in some cases, but certainly outperform the current designs that are used right now. Quick introduction of the Tesseract team: James Lancaster, CEO, 30 years experience in high-tech manufacturing and 20 years as an entrepreneur. I mentioned Henry, our inventor, 30-year mechanical engineer, experience in automotive structural components and 20 years in management. Jay Zgarba, supply chain, and Aaron Sakwich has recently joined us in a business development role. We do have Jim Terrell, Chief Financial Officer, and a to-be-announced manufacturing lead. I mentioned our crush tests, both physical crush tests as well as simulations, and we want to thank the Center for Collision Safety and Analysis at George Mason and the National Institute for Aeronautic Research at Wichita State University for helping us with those. We are talking to a couple of different OEMs and tier 1 industry suppliers. The tier 1 suppliers for potential outsourced manufacturing approaches as well as partnering in certain channels, and certainly we're talking to tier 1 suppliers from introductions and OEM partners. Realistically, we will outsource manufacturing for some components early on, but also that may be our exit path to some of those suppliers. Key UDO takeaway that I'd like to leave with you: number 1, we have the lightweight structural component that has the highest energy absorption and weight ratio, especially leapfrogs current designs, increases safety ratings in all the tests that we've performed our designs against, but we are very interested in partnering on a development project with an OEM or a tier 1 or 2 supplier. Thank you for listening to the Tesseract story, and I look forward to answering questions from the group. that key statement that our U2U absorbs more energy than any other approach by weight is what's relevant here. Number one, our materials are extremely lightweight. Number two, they fit in the existing hollow space of vehicles. Number three, they're very cost effective to manufacture and assemble and design. So it's an extremely weight efficient, cost efficient, and an extremely powerful solution to absorb energy in areas of the vehicle that largely have been absorbed. I mean, you have some very good years and years of crumple zones and energy load paths like the frame and the engine drivetrain that are designed to absorb a lot of energy. But, you know, that's left hollow fenders, number one, and a number of other places that are underserved. But the changing from a gas-powered vehicle to a battery vehicle and some creative approaches that the electric vehicle companies, creative locations that the electric vehicle companies are placing their batteries changes completely the crash profile of the vehicles. When you think about it, a battery, trying to maximize a battery for travel distance in a vehicle, putting under the frame is a very, very good, smart place to put it because there's big, broad space. But now instead of the door and other places being designed to help protect an occupant, are actually preventing a much bigger thing and a solid load mass underneath the vehicle that the vehicles weren't designed and didn't have years and decades worth of evolution of safety going into it. So it's a relatively quick redesign of the energy, the weight, and the mass, and what is placed under the frame when all of a sudden you decide, hey, we're going to put a battery into the vehicle. So we're targeting underutilized areas and in some cases ignored areas, or total redesigns of vehicles that have unexpected consequences for crash safety is essentially what we're doing.
Yeah, that also, I hope my microphone is working now.
It is, yes.
That also means you need to be involved in an early stage packaging decision when the whole vehicle concept is made. Do you,
we can, and most of our recent projects have been to upgrade the performance of existing product lines and to fit in existing spaces. In the future, if we are integrated with the team, we can actually design some of those concepts more tightly into it. We're not an aftermarket product, but we can be added late in the design cycle of an existing vehicle, or better yet, obviously would be involved early on. But we can certainly fit into the hollow spaces of existing vehicles, or and hollow spaces could be within a beam, could be in the frame component, could be in the door, could be in a variety of other areas that are just underutilized spaces with relatively cost-effective light components that can step up the performance of that particular part in the vehicle quite a bit.
Yeah, maybe also, I think we had an interaction like 2 weeks ago, and said we see these concepts today, and we also see what OEMs try to do by themselves, and they also come up with interesting design. So what do you say, how easy it is for you to protect your technology in terms of other creative people and OEMs kind of trying to copycat you?
Well, we obviously have put a lot of time and energy into our intellectual property and our design principles that are in that capability and stuff. But reality is, this is not an accidental discovery. It's not something that came very quickly. This was 25 years of Henry trying to figure out why that crashed, injured he and his wife like it did, damaged the vehicle. And you know, and how could be implemented physically, cost effectively, and lightweight. So because it was that many years worth of evolution, it's not quick and obvious for someone to implement it, which actually makes it relatively hard to step on in terms of intellectual property, because it's not a quick spur of the moment, you know, where someone says, gosh, I wish I'd thought of that. Yeah, that's some of that's in mind, but that's 25 years worth of thinking of that before the materials, the cost effectiveness, and the approaches were available. So there's a pretty good basis for the IP is what we've seen so far.
Very good. Thank you for additional comments. thanks all speakers. I want to see if the hosts have any other questions that came into our chat channel. But I don't have that in here now. So I think we're good. I would like to make one round on final comments, and that's maybe we can get all speakers from today with video and audio on. And I would like to do a little bit around and say, you went through kind of a non-profit acceleration competition with GAMIC. You are now here on the virtual stage with SAE. When you, maybe in one sentence, when you would like to request something more from the engineering environment that were here in this SAE community, what would be your invitation to the audience to reach out to you? Why should they contact you? And maybe we start with you, James, and then we work ourselves backwards.
Yeah, our obvious request, and it's kind of what we've been approached with customers so far, which is find an engineering need, a crash safety engineering need that's been a challenge, if not difficult or impossible to solve, and present it to us. We'd be happy to take a look at it and see if there's a light, cost-effective way to not just deflect and redirect energy, but to absorb energy in a way that's never been done before. And we'd love to have that engineering challenge. We'd be happy to engage with you, sit down to work with you, and solve that problem for you.
Thank you. Yes, sir. What is your outreach? What is your hand reaching out to the SAE community, to the GAMIC community? To why should people call you or send you an email tonight or tomorrow?
I would prefer tonight than tomorrow for sure. And so what we pride ourselves is that we are industry veterans and perception experts, that we build platforms. So we would love to learn the bottlenecks that that perception teams are having when they're building production grade machine learning solution. So come to us with your problems, and we would love to learn and then see if our solution would work to solve your problems.
Very interesting. Thank you. Awesome. What's your invitation?
Well, I mean, I would say to all my customers here locally in Detroit and to other customers here in US and other countries, well, we understand the challenge that we're facing today. And if you guys are struggling in terms of pedestrian safety, give us a chance. We believe we will make a difference here. We will believe that we can, work together to kind of create a standard in terms of safety, and hopefully to allow CES to be part of this and to kind of create a very standard safety for the automotive and autonomous companies to come in the near future.
Thank you. I hope your phone rings. By the way, you can always reach out to all the audience. You can reach out to the organizers, and they're happy to make the connection if you have not taken notes on like contact information. No problem at all. Hossein, why should people reach out to you after your presentation?
Yeah, so thanks Fabian and the SAE really for hosting this, although the presentation was very garbled. But what I would like to say is that we are an early stage startup, and we really need the backing of the SAE and the SAE community members, because the problem that we're trying to solve is very new, in the sense that this modality of battery safety does not exist today. And if you look at the landscape of the automotive industry right now, it's changing from internal combustion engine all the way to EVs. There's going to be new safety standards in how to, ensure that batteries don't explode as the range and fast charging capabilities keep piling on with newer and newer models. So for that, we want to be one of the enabling companies that do that. And for that, we need testing partners, validation partners, and really even the science of it is very new, as cell chemistries, battery chemistries, they keep changing over time. So basically we want to reach out to anybody who is interested in batteries and battery related safety, and be it ones or just even institutes, it really help us, propel our thinking and our understanding of deploying this kind of safety modality in battery packs for the next generation of EV.
Thank you. I think we already see here is we are in a world where, as a startup, we have to understand the problems of our customers, and especially in this business-to-business relationship. And I think that's why collaboration is the first step, and collaboration in SAE is definitely beneficial. Thank you so much for your presentations. For everyone else to share and forward, applications for the next season of GAMIC are open. If you know someone that needs to should present their technology, their business, please invite them. GAMICevent.org. Pretty easy to remind. Applications are open. Some minor questions that are asked along the way, and the pitch deck is requested. But then, until the end of October, all the applicants will be screened and chosen for the next season, and we are also looking forward to that. I'm happy that we all follow up soon, because also for you, I think your GAMIC journey is not over. It maybe just started with engagement and with the contacts you made during the season. And I thank SAE Detroit, the Detroit chapter, for inviting us. I apologize a little bit for the technical issues, but that's our world today. So thanks everyone for dialing in.
Thanks, Fabian.
Bye-bye.
Bye-bye.